scientific notation first. So we use scientific notation to show really big and really small numbers really accurately. So for example, if you look at all the numbers you see on the screen, those are really hard to read. Like you might know tenths, hundredths, thousands, ten thousandths, but then what? You might know thousands, millions, billions, trillions, but then what? It's too hard to say those numbers, so we use scientific notation. So what's the format? Well, it's a times 10 to the b power. So a is a coefficient, so that means it's between 1.00 and 9.999. Essentially, the number to the left of the decimal has to be a 1 through 9. And then the b is an exponent in integer, so a negative number like -3, a 0, or a positive number like 7. So how do you put numbers into scientific notation? Well, so here's a number, for example, you locate the decimal point, you move the decimal until a number 1 through 9 is to the left of the decimal. So I keep sliding the decimal point over until finally right there. Then you count how many places you move the decimal point. That was 10. And since the decimal is moved to the right, it was a small number, the exponent is going to be negative. So we can say we move the decimal to the right, the exponent goes down. It's negative, so it's downright wild. So we rewrite in this format, so you get this. Okay, this is something you should be familiar with, but quick recap. Here's another one. So find the decimal. In this case, there isn't one, so it would be at the end. Move it until a number 1 through 9 is to the left of the decimal. So I'm going to keep moving and moving and moving like this until a number 1 through 9. There we go, finally. Now count how many places you moved the decimal point, and that's how many places. Since the decimal is moved to the left, it was a big number, the exponent is positive, left up to you. And we rewrite in that format. So we get this, okay? So remember those big numbers? Look at that. So this number right here is a lot easier to say and read than this number, right? So how do you take numbers out of scientific notation? Well, you do the reverse. A negative exponent means it was a little number. A positive exponent means it was a big number. And a 0 as an exponent means you don't move the decimal at all. Move it 0 places. So here we have a number in scientific notation. Write down the numbers in front of the times 10. Look at the exponent and move the decimal that number of places. Add zeros to fill in when you need to, and there you go. So that's how you do it when it is a positive exponent, right? You're making a big number. So what about when it is a negative exponent? So I write down the numbers before the times 10, and then I'm going to look at the exponent so I can see how many places I have to move the decimal. I move the decimal the number of places I need to, and there you go. So that is how you do it when you have a negative exponent. All right, so here are some practice ones. So I'm going to put the answers up, but I would recommend you pause this and try these on your own first. Okay, big number, positive exponent. Little number, negative exponent. Don't need to move the decimal at all. Big number, positive exponent. Small number, negative exponent. And then here's practicing out of scientific notation. Again, I recommend you pause and try this, but I'm going to put up the answers. Positive exponent, big number. Positive exponent, big number. Negative, small number. 0, don't move the decimal. Negative, small number. Okay. When we multiply and divide with scientific notation, you just either multiply or divide. And if you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. So here's an example just to kind of show you exactly what that means. Okay, you just multiply and divide, and then you take care of the exponents. When you are adding and subtracting, you have to make sure the exponents are the same. So times 10 to the 5, they're both 10 times 10 to the 5. Then you add the coefficients, the numbers in front, and you just keep the same exponent. So here's an example of how that is. Notice the exponents are the same, you just keep those the same, and then you just either add or subtract the numbers in front of the times 10. Okay, that is a quick scientific notation, things you should remember, that this is the format a times 10 to the b. Okay. When you are counting significant figures, the only thing that matters is what's in the a. This does not matter at all for significant figures, at all. Okay. What else? This needs to have a digit 1 through 9 to the left of the decimal. Okay. Let's see what else. So when you have a big number, you are going to have a positive exponent for b. When you have a small number, you're going to have a negative exponent for b. And then we have the phrase down, right? So if the exponent, if you are moving the decimal to the right, the exponent goes down. That means gets smaller. So downright wild. And it's the same for thinking about it is left up to you. If you move the decimal to the left, the exponent goes up. Okay, so those are some things to remember. When you multiply, you add the exponents. You just multiply the numbers. When you divide the numbers and then subtract the exponents. And when you either add or subtract, you have to make sure the exponents are the same, and then you can just add or subtract the numbers and keep the times 10 with that same exponent. So, scientific notation.